Hello wonderful person, this is Anton, and in today's video I wanted to answer a simple question. If I were to take Earth and place it around other stars, where would I have to place it so it's still in the habitable zone? We're going to take a look at some of the more famous stars and find out how long the year would become for us if the Earth was orbiting something completely different. Welcome to What the Math. So we all know that 1 year around our sun takes about 1 year. That's why it's called a year. So it's 365 days. But we're going to replace sun with other stars and place Earth in the middle or maybe a little bit closer to the edge of the habitable zone just to see how long the year would actually become. We're going to go through some of the famous stars right here and just for now, try to predict which of these stars will actually give you the biggest possible year. Maybe it's a star you know, maybe it's a star that you don't. So, let's start a new simulation. And start with one of the smallest stars on this list right here, and that's Wolf 359. This is a red dwarf, a star that will live for a very long time, and as a matter of fact, this is the most popular, most common star in our galaxy. There's about 90% of all of the stars are basically like this. They're very small, much smaller than the sun. So let's enable the habitable zone by clicking this right here and place Earth where it would have been if it was orbiting in the habitable zone. Now this is where we think Proxima Centauri b is actually located, also known as Proxima b, I believe. And essentially this is where this planet orbits in its own solar system. So here the star looks pretty big. Earth moves relatively fast, and 1 year around this somewhat small star takes about 8.36 days. So basically, just a few days. In Proxima Centauri system, which is right here, this particular planet, Proxima b, takes maybe a little bit longer. I believe it takes about 11.1 days, and it's actually right in the middle of the habitable zone as well. And this is why so many scientists, so many astronomers are actually excited about the red dwarf stars, because we think this is where we might actually find our new home. It's much easier to find planets that are in a habitable zone around these stars, and it's very likely that we're going to see quite a lot of them, especially since the closest star to us seems to have a very Earth-like planet known as Proxima b. Alright, let's go to the next star. And let's pick Betelgeuse, which is a hypergiant. It's a very large star. As you can see, it's super big. And it is also one of the brightest stars in our night sky. So we're going to enable habitable zones, and then we're going to place our planet Earth where it would still have liquid water. So it's still in the habitable zone. And in this case, 1 year around this giant star would take about 1100 years, so just over 1,000 years, and this is what it would look like in the night sky. So here 1 year would actually be very long. And we don't really know if Betelgeuse has any planets, and if it does, they're probably a little bit closer to Betelgeuse than this, because we're actually at a distance of about 230 astronomical units. This is about 10 times as far away as Neptune is from the Sun, so this is actually a very unlikely event. But there might be a planet in this region, for all we know, and it might be habitable. Anyway, next on the list is going to be a white dwarf. Let's actually pick a white dwarf, and let's pick the one that's closest to us. Specifically, I'm talking about Sirius B. And in this case, it's actually about the same size as our Earth is, so it's a white dwarf that is very small. And so here, we might not even have an actual habitable zone. Oh, no, never mind, we do. And there it is. And we're going to place Earth right around here. And this is actually quite far away. This is at a distance of about 11 astronomical units. And here, one orbital period takes about 40 years. But I'm not actually sure if this is realistic, because look at how tiny this is. I think this might actually be a bug in the game. So this star is practically invisible. It would give us no light whatsoever. So I'm not really sure why in this particular region we actually have a habitable zone. I'm guessing it's a bug. I'm not sure this is how it works, but for all we know, maybe some white dwarfs have habitable zones where planets are actually located. Now, I also wanted to pick a very blue luminous giant, like for example Rigel, that's about 20 times masses of Sun. This is how big it is in comparison to our Sun. And here, the actual amount of light produced by this star is much, much larger than any previous star that we've investigated. And so here, as you can imagine, the distance is going to be much larger as well. And so look at that. We're now at a distance of about 39,000 or practically 40,000 astronomical units, and one orbital period takes about 1.7 years. Now that's actually kind of extreme. So it looks like this particular star is the winner so far. Rigel looks about this small from this distance, but produces so much light and so much heat that you would have to be really far away from Rigel for you to actually experience the same temperature as you would have on the real Earth. If, however, I were to place Earth a lot closer to Rigel, basically at 1 astronomical unit where it actually is in real life, look at what would happen to our planet. It would very likely become toast very, very quick. So this is a distance of about 1 astronomical units, and look at that. Our planet, our poor planet, becomes ridiculously hot, close to 5,000 degrees almost right away. And so this is what Rigel probably has, a bunch of planets that are super, super hot. Now there's actually quite a lot of other stars that are quite popular and quite famous that I wanted to place here, but let's actually just go into the extremes. Let's go into the most giant ones and see who wins this race. So far we have Rigel. Let's take a look at VY Canis Majoris and UY Scuti, which are the largest by size stars we've discovered so far. These are mega giants. These are so big that Sun, in comparison, is extremely tiny. And here, once we enable habitable zones and place our Earth, we'll realize that it's actually that basically Rigel is still a winner. It's a lot less than the year on Rigel. Here, the orbital period takes about 4,000 years, so that's for VY Canis Majoris, a star that used to be the largest star that we've discovered, but then we've discovered a new one called UY Scuti, and 1 year in this particular system for Earth to be habitable would be about 6,200 years at a distance of about 700 astronomical units. So once again, Rigel is still a winner. This is what actually the star looks like from this distance. And that's because the stars like Rigel or Deneb, for example, are actually super bright and super powerful. They release a lot more light and a lot more luminosity and a lot more energy than these red supergiants do. And this is why their habitable zone is actually so much farther away from the actual star. Now, is there anything else that is going to beat that? Well, if you originally said UY Scuti as the winner, or possibly Rigel, you might have been pretty close. But, however, in a galaxy that is not in the Milky Way, I believe this is actually from a Large Magellanic Cloud, there is another star known as R136A1. And this is, so far, the most massive star we've ever discovered, and it's such a massive star that we think that when it goes supernova, it's going to be ridiculously bright. So Sun is right there in comparison, and let's actually enable the habitable zone once again, zoom out, and find the habitable zone. And look at that. Look at how far away this is. So, if this star actually has a planet orbiting somewhere, and it wants to be a planet like Earth, basically, if that planet wants to actually have habitable conditions and be not super hot, it would have to be at a distance of 5 light years. One single orbital period here takes close to 10 million years. Now that is one long year. Imagine waiting for your birthday on that particular planet. And so I believe of all the stars that we have in the game, this right here might be the winner. R36A1, a star in the Large Magellanic Cloud that is part of one of the brightest, if not the brightest nebulae we've ever discovered, known as Tarantula Nebula, that is actually very far away, but quite easy to see because this star makes it so bright. And, well, that's all I really wanted to do in this video. Now we've discovered the star that has the highest potential orbital period, or basically year, where we would be able to place a planet and still have habitable conditions where liquid water can exist. And that star is R136A1. And the reason why it's the habitable zone for the star is so far away is really because of the huge mass that it has, close to 350 350 suns, and the temperature here is close to 55,000 degrees Kelvin. Very, very bright star, ridiculously bright star, high luminosity, a lot of energy produced, and that's why the habitable zone is so far. And anyway, you know what? Come back tomorrow. You're going to learn something very, very different. Something about space sciences, math, or just sciences in general. We're going to play a video game, and you're going to probably enjoy that video as well. Subscribe if you still haven't, and I'll see you in the next video. And anyway, space out. I'll see you later. Let's accelerate the game. We're going to go into millions of years just to see how this planet Earth is going to orbit around this star. And anyway, see you later. Bye-bye.